Number 1, choose the correct answer. If ED is a median in triangle ABC and ED half BC, then measure of angle A equal space. We have the median in the triangle here, and the line segment join between A and the middle of the opposite, because ED we called it the median. The median, it will be the line segment joined from A to the middle of the opposite side. And we have here ABC triangle, and ED is the median of this triangle, and tell us ED half of CP, then measure of angle A equal 90 degree. Okay, then the result will be 90 degree. Understood? Because AD is the median in this triangle, then the measure of angle A equal 90 degree. Understood? Then angle A will be right. Choose letter B. Question number 2. If D belong to axis of symmetry of AP, okay, axis of symmetry of AP, we have here straight line AB and point T belong to line symmetry. What about line symmetry? Line symmetry, it will be such that here L, it will be L perpendicular to the base and bisect it to side equal in lengths. And he tells us D belong to the line symmetry of AB. Then you can get the distance between A and D equals distance between B and D. It will be equality. Then ED will be equal BD. Choose letter B, equal to. Next question number 3. The triangle with sides 2 cm, x plus 3 cm and 5 cm is isosceles triangle when x equal what? We know inside in triangle, belong to the intervals difference and subtract between two sides. We have 2 and 5 cm. The difference between them 3, and if we add them, the result will be 7. Then the number lies between 3 and 7, and to get this triangle isosceles, it will be what? We have 4, 5, 6 lies between 3 and 7. So you must choose 5. Then 5 and 5 and 2, it will be side lengths of this triangle, because it tells us this triangle is isosceles. Then 5, we called it what? We have third lines here, it will be x plus 3 cm. He give us, look at here, x plus 3 cm, it's the side length in this triangle. Then x plus 3 equal 5. Okay, x plus 3 here equal 5. Then x will be equal to, okay, then the value of x here equal to, x will be equal to, because 2 plus 3 equal 5. 5 and 5 and 2. Why? Because this side, x plus 3, must lies between open interval from 3 to 7. 3 it will be the difference between 5 and 2, and 7 sum of 5 and 2. Understood? Next question. Sum of the measure of exterior angle of 4 equilateral triangle equal what? He wants to find the sum of measure of exterior angle. Exterior angle here is 60 and 60 and 60. We can find the exterior angle here 120 and 120 and 120. It will be what? 360 degree. The result will be letter D. Question number 5. The intersecting point of the median of triangle, divide it with the ratio 2 space from the base. We have here the median and this point. We called it the intersection point from 3 median, divided the median from the base 1 to 2, the ratio 1 to 2. He give us 2, then 2 to 4 from the base, because this line will be half of the line up. 1 half of 2, then 2 half of 4. Then you must write 4. The ratio will be 4. Question number 6. In the opposite figure, we have 5x and x, the sum of them, sorry, 4x, 5x plus 4x it will be 180. Then 9x equal 180. Then the value of x equal 180 divided by 9 equal 20 degree. Because we have two ray parallel, then the sum of interior angle equal 180. The value of x equal 20. Question number 2, complete. If 3 and 4 x plus 2 are side lengths of triangles, then x belonging to what? We have right here x plus 2 is belonging to the intervals here, the difference between 4 and 3, 1. And we have 3, okay, we have 3 and 4 centimeter of triangle, 3 centimeter and 4 centimeter. He gives us the third will be x plus 2. The third must lies between the difference between two sides and the sum of them. Then, if we put x only, you must cancel the value of x here by 8. Negative 2 to this interval, it will be negative 1. And negative 2 plus 7, it will be 5. Okay, we can cancel 2 by 8. Negative 2 to the first and the second. Then the result here, we must write what? Negative 1 and 7. Solution set. Open interval from negative 1 to 5. Question number 2, we have triangle ABC. We have AB was equal AC and angle 60, then it will be equilateral triangle because we have angle equals 60 degree and we have isosceles. If we have angles, the measure of it equals 60 degree and the isosceles triangle, then this triangle will be converted to equilateral triangle. Okay, then, and they give us parameter about this triangle was 12. 12 divided by 3 equal 4 centimeter. Then any side length will be 4 centimeter. Okay, write 4 centimeter here in this space. Next question number 3. In triangle ABC, measure of angle B equal 90 degree. And ABC here, measure of angle A 30 degree. Then AC, we have ABC triangle. Then he won't find what? AC twice BC. Okay, AC will be twice BC because it's 30 60 triangle. The side opposite 30 it will be half the hypotenuse. Then hypotenuse AC twice the side length of BC. Question number 4. The bisector of vertex angle in isosceles triangle bisects space and perpendicular it. Okay, question number 4. We have the bisector of isosceles triangle. We have isosceles triangle. It's bisector here. This bisector bisect space and perpendicular. Perpendicular to the base. Right, perpendicular here and the perpendicular it and perpendicular of it, perpendicular of it. Okay, question number 5. In triangle ABC, if AB equal BC, we have triangle ABC and he give us AB equal BC, measure of angle B 50 degree. Then we have equality angles in the base. We can find each measure of one of them. It will be 180 subtract by 50 divided by 2. The result will be 130 divided by 2. It will be 65 degree. Okay, measure of angle A equals 65 degree. Next question. In the opposite figure, we have triangle E, D, A, B and C. He gives us ED equal to CD equal to ED. There are equality here. Then this angle will be equal to this angle and this angle will be angle because we have isosceles triangle. We have equality angles there and equality angles here. Okay, He want to prove that what? Prove that BC greater than AC. Thinking with me about this. We want to prove that BC here greater than AC here. Okay, who can tell me the result here? We have equality between three sides. This angle equals this angle, this isosceles triangle, and this angle equals this angle. And if we want to find the length BC here opposite angle A greater than AC opposite angle B, you must prove that measure of angle A greater than measure of angle B. Okay, first step, we have X and X. You know, measure of angle A, measure of angle X here, it will be greater than measure of angle B. Why? Such that in triangle, we have in this triangle EPC, we have such that E was falling to AB, straight line or line segment, then the measure of angle X will be greater than angle of B. Okay, measure of angle X greater than angle of B, and such that in triangle EAEC, in this triangle here, we know measure of angle X less than measure of angle A, because X equal X and we have this angle, then A will be greater than X. Measure of angle A will be greater than measure of angle X. It will be relation number 1, and here relation number 2. X greater than B and A greater than X, then A greater than B. Then from relation number 1 and relation number 2, measure of angle A greater than X and X greater than B, then measure of angle A greater than measure of angle B. Then in triangle, biggest triangle here ABC, we found here difference between two angles, then the greater angles opposite the height side, then CB will be greater than the side opposite B, it will be AC. Okay, then CB greater than AC. Examples here very important. Okay, you must pay attention about steps in this example. Next triangle, we have isosceles triangle here, BC isosceles triangle, then angle of B will be equal angle C, and he give us measure of angle A equal X and measure of angle B twice X, then this angle will be twice X angle, such that AC was equal AB, then measure of angle B equal measure of angle C in two pieces. Then we know the sum of inter angles in a triangle equal 180, then 2x plus 2x plus x equal 180. 3x plus 2 plus 2 4 plus 1 5, 5x equal 180 divided by 5, x equals 36. The value of x equals 30. Then measure of angle C, it will be twice x. Measure of angle C equal 2x, 2 times 36, it will be 72 degrees. Next question, we have triangle A, B, C, and we have the bisect, AT bisect base, CP equal two lengths, D is the midpoint. He want to find the parameter or prove that parameter of triangle ADC, this triangle, greater than parameter of triangle ABD. Prove that triangle parameter about this triangle greater than parameter of ABD. How we can solve this? He give us this point in the middle. Okay, first step to get this parameter, we can find the properties about any triangle. The inequality tell me if you add any two sides in triangles, some of them will be greater the third, such that in triangle ADC, this triangle, in this triangle ADC, we have EC plus CD greater than AD. Okay, and I want to find the triangle or parameter of ABD. Okay, the parameter about this triangle greater than the parameter of this triangle. How we can do that? We know AC plus CD greater than AD. And complete with me about another triangle here. AB plus BD was greater than AD. Okay, and if we add two relations with them, we have EC plus CD plus BD, CD plus BD, it will be CB. Then you can cancel them to parts here and write CP. And write AB greater than twice AD. It's okay. And AC plus CP plus AB, it's parameter of triangle ABC. It's greater than twice ED, twice of AD. Then we prove that the parameter of triangle ABC greater than twice AD. It's relation number 1. And we can find the side AB here plus BD, AB plus D less than AD. It's parameter of triangle here. Okay, we want to find what? AD here, twice of it equal what? Twice AD. We can find the new relation. Its relation contains of AB plus BD plus DA. How we can find it? We can find it in this triangle. We have AB plus, but you want to find what? The parameter about this triangle ECD, okay, or EDC, not this great triangle. Then it's relation number 1, okay? And I want to find the relation between two triangles here and here. How we can find the relation between them? Okay, we can write EC plus CD greater than ED, and we have EB plus BD was greater than ED. Okay, we can cancel ED here. How we cancel ED to find the parameter of ADC? ADC here, I want add the side length here. I want add here AD, okay, and here AD. Then twice AD less than the parameter of a parameter of C of triangle ACD greater than twice AD. Okay, it's relation number 2. And I want to find the parameter of ABD. We can write EB plus BD greater than ED. If we product by 2 here, or we can add ED to left hand side, right hand side. Add ED here, it will be twice ED less than what ED here, and ED is the parameter here of this triangle EBD greater than twice ED. We have two relation here, D in the middle of the midpoint. Then you can find in relation about this example the parameter about triangle ADC. We want put greater than about parameter of EBD. Okay, we can write this sign here. Thinking with me, EC plus CD, it's parameter about this triangle, EC plus CD plus DA. And this triangle we can write EB here plus AB plus BD plus DA. DA, we can cancel it. Then EC plus CD will be greater than AB plus DC. Okay, you can put these properties from the equality about any triangle. The sum of any side any triangle greater than the third, CA plus EB was greater than CB. Okay, it's the properties about any triangle. And CB equal to parts CD then CA plus EB greater than CB equals CD plus DB. CD plus DB. And we have CA and AB. Okay. We want to find the parameter here and parameter here. No, it's a false example. Okay. This example, we have the solution set, the parameter of triangle ADC greater than twice ED. Okay. We can cancel this and write twice ED. It's wrong question. Okay. Next question. We have triangle ABC. Measure of angle A 75 degree and the measure of angle B 40 degree. Arrange. You can find the measure of angle C by write 108, subtract the sum of them. 75 plus 40. 5 plus 0 equal 5. 7 plus 4 equal 11. 10 minus 5 equal 5. 7 in 6 equals 65 degree. We have three angles here. You want to arrange descending lines. The descending here, the first 75 opposite CB and 65 opposite AB and 40 opposite CA. Okay. Next question. We have triangle here. We have A, B and C, and we have the 12B equality. He give us AB equals 13 centimeter and BC 10 centimeter. Okay, he want find the length of BD. We have isosceles triangle and it will be perpendicular, then AD will be bisect the base, such that AD perpendicular to BC and AB equal AC, then D is the midpoint of BC. Okay, then DB equal side length, then DB equal half of 10, it will be 5 centimeter here. Then we can write AD square root of 13 power 2 subtract by 5 over 2, 169 subtracted by 25, square root of them, it will be 12 centimeters. Then ED will be 12 centimeter. And then we can find the area by half times the base times the height. The base was 10 and the height was 12. Half of 10, 5. 5 times 6 equals 60 square centimeter. In the opposite figure, we have triangle here. It's L and X and Z. X and Y and Z. And prove that the parameter of this triangle twice XL. Okay, it's correct. But in this example, last example, we have the error in the example. This example is error. Okay, you must write this example such that this. He give us D in the midpoint, and he want to find prove that the parameter about triangle ADC greater than parameter ABD. How? No, it's not. Because D is the middle point here, then AB, D and ACD will be the equality between them. It's the middle. But if he give us the change about EC and EB, I will solve it. But this example, the root of satisfies about this equation here? No, it's a difference. We have change. He must tell me EC and EB relation between them. He must give the relation between greater than less than. Don't give me this example. This example must be like write this example because it's a famous question. Okay, you can find the parameter about XYZ by write two relation about the first triangle. In triangle number 1, we have XY plus YL greater than XL. And in triangle number 2, we have XZ plus LZ, XZ plus LZ greater than XL, and we can add two relations here, relation 1 and relation number 2, each of them, XY plus YL plus XZ LZ greater than XL plus XL twice XL. Then you can write XY here plus XZ and LZ and LY. You can add them to get YZ greater than twice XL. Okay, it's correct answer because this question is true. But in the last question we have the error about this example. We missed the new solution about it. We made in the example a new relation between EC and ED. If he give us in this example EC less than ED or D lies to nearest to CD, I will solve it. Okay, but this incorrect example. Okay.